Welcome back to the shop. I've had this rotary table. It's just a little 8-inch rotary table for quite some time now. But I'd like to make it just a little bit more useful. I have this old 3-jaw chuck that I'd like to mount to it. I think this would be an extremely useful tool to have in the shop. And to that end, I picked up this 8-inch piece of steel, and if I drill some holes in just the right place, I could turn this into an adapter plate for this little 6-inch chuck. I don't expect this thing to end up being a super precision piece of tooling. However, I would like to give myself the best chance I can to get a good flat surface that these are all mount on. So what I want to do now is to clamp the piece of steel, that round piece of steel in the vise, so I can take the fly cutter over it and at least get one side flat. So if I move the hardened jaw face from the movable side of the vise jaw, it'll give me a little area that I can set the steel plate on and get it clamped to the mill table for the fly cutter. I'll set a parallel on the fixed side of the jaw that's the same height as the movable jaw. And I'll also take a couple of small wooden shims just to give me a little bit of, I guess, extra clamping area. I think this might spread the clamping force out around the radius of the flat steel, and it should keep it fairly secure in the vise jaws, and I won't really have to worry about this thing popping out on me. Got the fly cutter mounted in the spindle now with my lathe tool. I'm setting this up so that the cutter will extend just past the 8-inch diameter of this steel plate, so I can do this all in a single pass. Well, if I want to do this as a single pass to where the fly cutter traverses the entire surface of the plate, I'm going to have to move this vise over. It's just a little bit too far to the left. Just using a piece of paper here to set the depth of cut here, my initial cut. I'll raise the knee up until the paper gets a little bit stuck in there, and that way I know I'm about 3 or 4 thousandths away from the surface. Alright, so I have the spindle here running at around 350 RPM, and I'm feeding the table at around 1.5 to 2 inches per minute. Well, that first pass wasn't terrible, but it also wasn't great. So I'm going to put a new edge on the insert here and take another pass. I've had good results with these CCGT inserts. It's got a ground edge on it and a tighter radius on the corner of the cutting edge. Gives me a really good finish, so I think I'll run the second pass with one of these. I'm always impressed with how good this little cutter does, considering I made it in about an hour and a half or so. Well, with this side here now nice and flat, I'm going to use it as my reference surface. I've already used some layout fluid to mark some holes that are going to be on the other side. There's going to be a bore in the center, just going to be registration, and then 4 holes to mount it to the rotary table, and then 3 holes to mount the chuck to this plate. Now these marks that I put on here are holes that are in their approximate locations. Their exact location may vary a little bit. It's just a way of hoping that Mr. Bozo doesn't come to town and I end up completely screwing this up. And because I'm going to clamp this straight down to the table, I need to pull these T-slot covers out. So I'm going to use these 1, 2, 3 blocks now to raise it up off of the mill table, making sure that the placement of these blocks is not going to be in line or interfere with any of the holes. And now with some studs into some T-nuts here, I can use some toe clamps and riser blocks to get this good and solid onto the mill table. Now I am going to set this up on my center here. I've got a wiggler in the spindle. I'll use this little block of wood to kind of calm it down until it's fairly straight, and just locate that center punch that I put in a while ago that should be close to where the center is. I'm going to end up machining the circumference, so it's okay if this is not exact. Just moving the table back and forth here left and right to see how well I lined up on that center line, and I just did it by eye, and dang if it wasn't within maybe a millimeter spot on. So not that it's important, but it's nice to know that I'm going to get close to where these holes need to be. I'll start with the 4 mounting holes that will hold this plate down to the rotary table. I'm using the pitch circle diameter function on the DRO to drill 4 holes with a diameter of 7.2 inches. I thought that this being an 8-inch rotary table that should be fine. We'll later find out that that was a mistake. I should have had that diameter a little bit narrower. With the PCD function, all I need to do is select which hole I want to go to, and I just traverse the X and Y until I get to zeros, and I should be right exactly where the hole needs to be. I first start with a 1/4 inch 120-degree spotting drill. And since this will be held down with 5/16 inch hardware, I'm drilling 11 32 inch clearance holes. I just need to do that now 3 more times. I just use the DRO to select the next hole, and then I again traverse the X and Y until the dots line up and everything reads 0. One of these days I need to go into the settings on my DRO and fix this y-axis. It's backwards according to the DRO. Not a big deal, doesn't change anything. Just, I guess I'm going to have to pay attention to the numbers more than where the dot is. I still need to counterbore those holes for some socket head cap screws, but before I take the drill chuck out of the spindle, I want to drill a pilot hole for the large bore that will go in the center. Now this center hole is just going to be for sort of an alignment pin that I'm going to make for the rotary table. That's going to be about 1 3/8 inches in diameter. So I'm just going to go straight to the 1-inch Silver and Demings drill I have. And I think that's just a little bit too much drill. So I'm going to go ahead and remove this and start with something a little bit smaller. I'll step down here to 7/8 inch drill. Okay, so now this 1-inch drill is going to have a little bit of an easier time than it did before. The last thing I need to do here before I take this drill chuck out is to drill the clearance holes for the holes for the chuck. I did the PCD function again on the DRO to make a hole pattern that's on a 3.866 diameter circle at 120 degrees apart. And since I'll be using 3/8 inch socket head cap screws, these clearance holes are 13/32 of an inch. Since I don't have any piloting counterbore drills, I'm switching here to a 1/2 inch end mill to counterbore the 4 holes that are used for the table hardware. I'm boring these to a depth of about 3/8 of an inch. It's a little deeper than you really need for this size hardware. However, I do plan on coming back and fly cutting this side of this plate, and I want to make sure I have room to do that. Well, the next operation is to bore out that center hole to 1 3/8 of an inch. This is my first time actually using this boring head or any boring head. This was actually given to me by a friend of mine, DJ. Thank you again, DJ. He came with a straight shank on it. I have since purchased an R8 shank for it. I didn't have any boring bars for it, so I went on to Char's website and ordered this set of boring bars with brazed on carbide. I'm going to use the power down feed on the mill here, so I'm going to set the end stop to where that'll kick out just after the carbide leaves the bottom of the bore. Well, I find it extremely difficult to read the um, divisions on the dial to increase the diameter of the bore. So I'm going to set up a dial indicator here on a mag base to make that a little bit easier for me to know just how much more I'm taking off of the radius. I use a telescoping snap gauge here to check my progress. Take another measurement here. I know I'm probably pretty close, within 2 or 3 thousandths. This should be the last cut on this bore. use the telescopic snap gauge again to take another quick measurement here. I should be right where I need it to be at 1 inch and 375 thousandths. Well, with all the milling operations done on this side of the adapter plate, I can go ahead and remove the clamps and clean it up and get ready for the next part. Well, this video is getting a bit long, so I think we're going to go ahead and wrap it up and end it here. There's still quite a bit I need to do to this before I can get the chuck mounted on it. So stay tuned for the next part. If you like the video, give it a thumbs up. It really does help a lot with the YouTube analytics. And if you're not a subscriber, hit that subscribe button. Hit the bell icon so you'll be notified whenever I publish a new video. I really do hope you enjoyed this. We'll see you on the next one. And thanks for watching.